As of a week ago, the Gaia spacecraft is no longer operational. Everything's fine with it, it's just come to the end of its life and its propellant, and so has now been moved to a heliocentric orbit. But what kind of spacecraft was Gaia? What did it see? And how has it contributed to astronomy? Well, stick around and let's find out. I'm Seti. I'm a PhD student studying galactic dynamics with a focus on the Milky Way, which, yes, is coincidentally what Gaia was also made to do. I pretty much talk about any and all areas of astrophysics and space, such as black holes, really big missions, planets, galaxies, and much, much more. If you're interested in this kind of content, I highly recommend you subscribe and watch my other videos, but for now, stick around and let's talk about Gaia. Gaia is a Milky Way mission at its core. It took measurements for at least 1 billion stars in our galaxy, but I think the figure's actually approaching 2 billion now, which is a huge amount, but let's also remember that that is probably at best around 2% of the stars in the Milky Way. However, on top of the stellar component, Gaia has also been able to indirectly detect a few thousand exoplanets, either looking at the star's radial velocity or just measuring a regular dip in its brightness. I do have an article linked down below if you'd like to learn more about exoplanet detection. In order to observe all of these targets, on board the spacecraft were 3 important pieces of tech. The astrometer, which was used to pinpoint a star's position and how it's moving through the galaxy, the blue and red photometers, which tells us how bright the star is and its colour, and together with the astrometer you can determine its luminosity, surface temperature, size, and a couple other stellar properties. Some of you might be thinking, well, this is just a very overcomplicated way of using Stefan's law or Wien's law. Well, these laws are kind of true and very reliable when a star's in its main sequence or in a very stable phase of its life, but quick parts of the stellar cycle, such as the helium flash, which I feel like the name kind of gives it away there, they're very theoretically, quite well understood, but observationally they're very difficult to actually capture, and that's because of how quick they are. So having a dedicated mission for phases like this that look at a star in very close detail can really shed light on these parts of a star's cycle. Furthermore, stellar properties hinge on how well we can estimate a star's power output and the colour of the star, accounting for redshift. And these depend on distance, which are probably one of the hardest things to estimate just in general, so one of Gaia's main objectives is to improve our parallax distance measurements. There's one more important piece of equipment, and that is the radial velocity spectrometer. Now, not all stars that have been measured with the other 2 instruments will have been measured with the spectrometer, but the ones that did would have been able to have their full proper motions and kinematics fully mapped out. In astrophysics, having all 3 coordinates, so x, y, z, and the velocity versions of that is called having 60 phase space, with 2 of these velocities typically being just across the sky, so left and right and up and down, but then also line of sight, so going towards and away from you, with the last one being measured by the radial velocity spectrometer. So most of the stars will have just been missing this final component and would have just only had 5D phase space information. Now, let's go on to the important results. A lot of Gaia's findings and, discoveries are very well detailed in hundreds of papers that have used its data. So it's actually it's a bit of a challenge to sort of present something very concise here, but we should start off with Gaia's spectacular view of the Milky Way. This image contains well over 1 billion of the Milky Way stars. I think it's actually approaching 2 billion stars in this image, and these were taken using the photometers. You can see along the disk of the galaxy, which is in the middle of the image, there's a lot of gas and dust that's mixed in with the stars, but behind that, near the center, is the bulge, which is noticeably much brighter and much yellower, and it also hosts Sagittarius A star, which is our resident supermassive black hole, one of the smallest we've actually observed. Moving away from the disk and looking at the rest of the image, you can see a wide mix of halo stars and globular clusters. You can also see these slightly larger but very, very bright dots in the background, and these are actually other galaxies. These 2 are a notable pair. I'll give you a second to guess which ones they are. Okay, I'll give you one hint. They are both Southern Hemisphere objects. Have you guessed them correctly? They're the Large and Small Magellanic Clouds. I should also mention that some of the stars that Gaia has directly observed are also Magellanic candidates, so these are stars that are probably part of the Large Magellanic Cloud. One of my favourite discoveries that involved the Gaia spacecraft was the Gaia sausage, or Gaia enceladus. So Sometime around 10 billion years ago, our galaxy collided and engulfed a companion galaxy called the Gaia sausage. But it doesn't exist anymore, so it's kind of difficult to figure out what it was like as a galaxy. But we know that it was probably less than 1% the Milky Way's mass, so a very, very small galaxy. At least 8 clusters were merged into the Milky Way, but which one was the core of the old galaxy? It's kind of up for debate. Some say it's NGC 2808, but I'm thinking it could actually be Omega Centauri. It's difficult to say. Gaia also discovered Antela 2, which is a very close companion that's much fainter than any galaxy seen before, despite its very small distance to us. Judging by the looks of it, it seems as though it's undergoing a tidal interaction and it's getting turned into a tidal tail. Seriously, going through all of these papers and these discoveries has kind of humbly reminded me of how many companions the Milky Way has. The final result I want to talk about is the fact that Gaia has helped us understand way more about the disk in the Milky Way. We've been able to view the warp better than before, and we can now pretty definitively say that it's processing prograde somewhere between, like, I don't know, about 5 to 15 kilometers per second per kiloparsec. And I think furthermore, Gaia has helped us understand that we need a lot more research into the disk, but that's why I'm here. Gaia currently has 3 data releases available to download and mess around with. I say that lightly, we're talking about hundreds of terabytes of data, so it's not something the average person can actually, work with. The successor for Gaia is going to be Gaia Near Infrared, or Gaia Near, which aims to look more into the infrared section of the electromagnetic spectrum. That's all from me, guys. Remember to like and subscribe. If you're interested in making a mini Gaia and you can crochet, I actually do have a crochet pattern for the Gaia spacecraft on my Ravelry. I'll link it down below. But with that being said, thank you very much for watching, and I shall see you in the next video.